Okay, we're going to finish up Module 12, looking at the continental shelf. And today we're going to key in specifically on the kelp beds, okay? So here we go. Hard substrate of the continental communities are home to rocky bottom seaweeds and other sessile organisms, namely, what do you find living here? The kelp forests. We've talked about the kelp forests already when we learned about what kelp was. Remember, it's not in Kingdom Plantae, it's in Kingdom Protista, right? Algae. So we can see that these areas serve as a food source and protection. So this is sort of like a protective coral reef in a different form, right? So that animals are living amongst there, just like animals living amongst the coral reef for protection and food sources and stuff like that. Many animals, algae, other seaweeds. Kelp beds and forests. Remember, kelp is not a plant. It does not have roots, stems, or leaves. It is an alga, would be the more accurate way to say that. An alga, or it is in subkingdom algae, kingdom protista. But they do serve to clean the water and as a spot for other creatures to live. All right, so if we look at it here, we can see that the kelp beds in the winter might have less growth, and the summer it's just going to have more growth. Here we go. Here comes the springtime. So let's look at the difference. Winter and spring. Did our bottom? No, it didn't change. It's all the same there. Okay, so we can see they definitely have seasons that they go through. Let's watch a little video.
This is underwater video of a kelp forest. Now remember, in order for it to be a kelp forest, the kelp must grow tall enough so that a portion of the kelp actually floats on the surface of the ocean. This forms a canopy for the forest. If the kelp aren't tall enough to form a canopy, the community is called a kelp bed. Kelp thrive in cold, nutrient-rich waters, while coral require warm water to grow. As a result, you don't find kelp forests and coral reefs together. In fact, if you look at the distribution of the two, kelp tend to be where coral reefs are not. A kelp forest is a rich ecosystem that supports a wide variety of marine life. Seaweeds and other algae grow among the kelp, so there are rich sources of primary production here. Interestingly enough, the bodies of the algae and the canopy at the top of a kelp forest shade the substrate so that it is very dimly lit. Despite the fact the kelp forest can be dim, especially near the bottom, animals inhabit all levels of the kelp forest. Some even make their homes directly on the kelp.
All right, here we go. We have requirements for kelp growth. Cold water. This is going to be kind of different, almost opposite of what we see for the coral reefs. They do need sunlight, however, just like the corals do, for the photosynthesis, because of course the algae do perform photosynthesis. They need a hard substrate, because remember the bottom of it has that thing called a hold fast. It's going to hold fast onto the hard substrate. And then we have cold currents. The currents will serve, of course, to bring in nutrients from other locations. So we have the nutrients for the creatures living amongst the kelp. All right, so 4 things. That looks like a good quiz question, yeah? All right, so here are some different forms of kelps and algae. We looked at red algae, green algae, and brown algae, right? So here's our brown algae, the one on the left here. We're going to look at these specifically, the bullwhip and the macrocystis here in just a minute. We have red right over here. Sea lettuce, right? These are all different types of the kelp here. We're going to see the traditionally kelp. This is the brown kelp right here. It can get really tall. Very tall. Here we're looking at the forest. This is why they call it the forest. It looks like tall trees up there and that sun shining down. So pretty cool stuff. Here's another view of that. So you have another map in your book there, like you did for the coral reefs. So if you turn the page, you'll see that map. So it says here we're going to shade in the location of the major kelp forests of the world. Notice you'll not find them in the same place as the coral. Okay, so the coral, remember, we're kind of isolated that center section, that tropical area. We're going to see the kelp is in different locations. And so if you'll color in some of these areas here. Oh, and it does tell us a little bit the types we find there. Laminaria and our Macrocystis neurocystis here along our shore. Macrocystis here. And let's Eclonia. We're going to get those words here in just a minute, so don't worry about writing those yet. So notice in the center where the tropical region is, we don't have any kelp forests there. So we're going to see there in different locations from the coral. So that's kind of a nice deal where creatures live that don't have corals for protection. They'll live in a place where they'll have kelp forests for protection. How about that? Thank you, God. Pretty good? Generally in the colder regions, right? Toward the poles. So remember, in America, the only place we can find any semblance of a coral reef would be in the Florida Keys. That's the closest we would have to tropical here. Because the equator's about right here, where Ecuador is. Not in the same places as coral reefs. I think that's the question. Will you find them in the same place as the coral reef? In your notes, you'll say no. That is a question in there. All right, so back on the previous page, not the map page, you're going to have a spot, you're going to draw this. Sketch the parts of kelp, which I think we talked about this before, and I asked you if you were supposed to draw it, and I think you weren't. And that's because we're going to draw it here. That's why. All right, so we did talk about it. We probably looked at this exact same picture, in fact. So we're going to see how they don't have leaves, stems, and roots. They have blades, stipes, and holdfasts. So different names that perform different functions. That's why we call them different things, because they're not actually a plant. I would not be surprised if this were a quiz question. So we'll have a quiz the next time we get together, but it's not next week, because next week is spring break. So the week after that, we'll get together for a quiz on this. And moving on to module, whatever, 13? 13 out of 16?
But I didn't know this would be spring break.
Yeah, it seems like it came really early this year. Because today's what, only the 5th, I think, right? March 5th? That also means we're going to lose an hour. I don't know about y'all, but I hate to lose an hour. Remember those little gas bladder things are to help it float, to keep it near the surface, to be where the sun is, right? And they're called, okay, pneumatocysts, right? Not nematocysts are the stingers. P-N-E-U, pneumatocysts. But I'll accept the gas bladder like that. That's our air bladder even. That works. They do have gas in them to give it buoyancy.
What is frond?
So if we take the whole thing together, not counting the holdfast, so the stipe with the blade, we just call that the frond. Okay, we good? So we can see a picture of it there. Beautiful. Flowing. We've got some current going, making it move. Here's a really dramatic hold fast. Holding very fast. Reproduction. Okay, we have in these, just like the algas that we've talked about before, we have something called alternation of generation life cycle. It's going to go through the haploid and the diploid. It's going to go back and forth that way. It means that the reproduction alternates between spores and gametes. So that would be between asexual reproduction and sexual reproduction. We see that all over, like on land plants, we'll see that, like namely ferns and things like that. Okay, so alternation of generations. We can see here that the gametophyte generation, you're going to write this down, the gametophyte generation characteristics. They produce haploid gametes, that's the bottom line. 2 haploid gametes meet to fertilize and the result in a diploid cell. That would be, of course, sexual reproduction. So I think what you're going to write down for gametophyte generation produces haploid gametes. If something's haploid, that means it only has half of the genetic information needed for the organism. And if that's the case, it needs to get the other half from somewhere, right? That's how you know that this is the version of sexual reproduction versus asexual reproduction. All right, so that's called the gametophyte, makes a gamete. Gives it away right there in the word. So what do you think the sporophyte generation makes? Spore, right. So the sporophyte generation characteristics, a diploid generation produces diploid spores that germinate instead of gametes. So it produces diploid spores. Diploid has all the information it needs. Remember, a spore is a little bit like a tiny seed. A tiny seed without the package of food in it that normal, like angiosperm seeds would produce. All right, so a sporophyte generation is going to make spores. Gametophyte generation makes gametes. Sporophyte generation makes spores. And what it does is it alternates between those. All right, so if our gametophyte generation is going to make gametes, haploid, they're going to fuse to become a diploid zygote, which will go through mitosis, making the sporophyte, which will go through meiosis, making the spores into our N generation, filling up that gametophyte generation that these will be turned into the gametes for the N. So we have 2 N down at the bottom, N at the top. You can see how it's going to go back and forth and back and forth. It's really a very efficient way of going through reproduction, right? They don't have to depend always on a mate. All right, here comes the big words. Ready? Types of kelp. First one, Egregia, better known as feather boa kelp. I'll show you a picture of it. You'll see why it's called feather boa kelp. So you have, I think, 6 boxes there to write down these 6 different types. So if you just write down, if you want to write down feather boa kelp for you to remember, if you have room, that's fine. But otherwise, just that word, Egregia. And if remember that map I showed you, it had actually some of those names on there, right? Laminaria. I think it had it up on our east coast. Number 3, however you want to pronounce that, Eisenia. Nerocystis, this is definitely one we have in America. It's also known as bullwhip kelp. Calliarthrin. And probably the most common would be our Macrocystis, known as giant kelp. So spelling challenges is what I would say here. I don't count off for spelling as long as I know what you're trying to write. But mainly you need to know there are 6 main types of kelp, large kelp. Okay. Giant kelp grows only where the water's deep enough to reduce, to reduce wave action, but shallow enough to allow light to penetrate into the substrate. All right, and we can see from the picture, we're looking up at these look like gigantic trees, right? So that's where the forest idea comes from. Here's our bullwhip kelp. Look, it has that long stipe with all of its fronds hanging off the end like a little whip. It lives closer to the shore because it can tolerate slightly more wave action than the giant kelp. All right, so it moves around. It probably looks pretty cool while it's moving around in the water. And then here's that feather boa, right? You see why it's called, you know what a feather boa is. You wear around your neck kind of a thing. Lives in shallow water and can survive stronger waves. It's a little more compact and therefore kind of tough that way. What will you find living amongst, I'm going to say amongst the kelp forest, because in the kelp forest, well, there's kelp, we just talked about that, but what else is living there? So we're going to watch a video about it. In fact, watch and take some notes from the video, okay? Write a few things down.
Let's visit an underwater forest near Monterey, California, where kelp grows tall, reaching toward the sunlight above. Its fallen blades litter the seafloor below, providing nutrients for a host of creatures, including these spiny purple sea urchins, which move slowly in search of food.
There's something, sea urchins.
Sea urchins make a tasty meal for this marine mammal. Sea otters help keep the sea urchin population in check. Too many sea urchins will devour living kelp, destroying the forest. We consider otters a keystone species. Their sea urchin diet protects the kelp and helps to maintain diversity and balance in this ecosystem. But we're seeing just one small part of an intricate network. Sunflower stars also prey on sea urchins and may become dinner for a hungry sea otter. But otters prefer abalone and crabs. Kelp provides food and shelter for snails as well as crabs and their tiny crustacean cousins. They find some protection among the kelp blades, but small fishes can still surprise them. All these animals and plants are immersed in a rich food source, a sea of microscopic phytoplankton drifting in the water. From the smallest microbes to the largest animals, these species take part in a diverse food web that links more than 1,000 species. The connections in the web represent the transfer of energy with every meal. Where does all this energy come from? Our star, the sun, drives all this activity. It supplies energy for almost all life on Earth. Kelp and phytoplankton, with their ability to capture the sun's energy, are known as primary producers. We consumers would be nowhere without them.
All right, got a few things written down there? So we can see these predator-prey relationships. So this is from the video, right? So we can see that when they were talking about the food web kind of a situation, right? So we had the urchins, we had the otters, we have these fish, we have sharks, all these guys. And predator-prey obviously is going to be a balance, keeping things balanced in the ecosystem. So our sea urchins, we can see some here, it looks like quite a few starting to try to take over. Sea urchins are really cool. That's what we're going to do today for our lab. We're going to dissect a sea urchin, do it a little differently for marine class to try to see if we can see a little more action, and then we'll be using our scissors and things like that. All right, let's see this.
Along the coast of California, ocean currents carry a constant supply of nutrients up from the depths to the surface layers. These upwellings fertilize forests of giant kelp that thrive in the summer sunshine. The algal towers are as high as a 3-story house, and they can grow by 0.5 meter a day. Life in the kelp is as full of drama as in any other forest, but the cast is less familiar. An army of sea urchins is mounting an attack. The urchin plague strikes at the kelp's holdfasts, their crucial attachments to the rock. Holdfasts are extremely tough, but each urchin has 5 teeth, which are self-sharpening and are replaced every few months.
Oh, that's creepy.
Urchins fell vast areas of kelp forest, creating clearings known as urchin barrens. Yet, barrens is a poor description. Millions of invertebrates invade the seabed. The most fearsome predator here is a giant. The sunflower starfish is a meter across, with an appetite for brittle stars. It uses its feet to taste for prey. When its actions are speeded up, it becomes clear that the predator's fondness for the brittle stars is almost matched by the brittle star's ability to get out of the way. Sand dollars, flat sea urchins, cluster together as a defense. But it doesn't seem to work against the sunflower starfish. The predator extrudes its stomach and wraps it around its victims, liquefying their soft parts. Nothing is left of them except their white skeletons.
That's a little creepy, huh? All right, this is a picture from that video, right? So we can see the sea urchin. Remember how it operated in its destruction here would be to chew through the holdfast, and then that giant kelp will just float away, right? It's going to have, it doesn't have its property left to it to continue to hold on there, so it ends up just wrecking entire forest. So we need to, of course, control the sea urchin population. Look at this cool sea urchin. It's called the flower sea urchin. You can see why each one of its little tentacles that come out look like little tiny flowers right there. We're going to see when we look at it that the spikes on the sea urchin have 2 different functions, right? So we have does it tell us sharp spines? And then here's the mouth. Does it not show us? Okay, because it also does have some tube feet, like our starfish, right? So part of those things, projections coming out, are softer, and those are the tube feet that cause the water to flow through and this kind of thing. And then the spines, of course, are going to be sticking out on something known as the test or the skeleton of it right there. I've always often said that the mouth parts are probably the most interesting part of this creature. We're going to try cutting it so that we have a top half and a bottom half, and we can try to see all the parts in there. Instead of, like with my younger students, I'll just literally just take the mouth out and take a look at that. So here are the tests. They look like this. I have a test we can look at today. I think we've already seen it, right? Didn't we look through it and you can see all the holes? And then if you looked at, this is an interesting picture. It looks like a spaceship to me. You see, so we have the mouth part right here, takes a good portion of the space on the inside. We have quite a hollow spot here, and then we have the gonads, and we have the guts, the digestive system here, and then we have the structural system here, the skeletal system, if you will. Here's another picture showing it, looking like a little spaceship in there. All right, so this is what it's going to look like when we dissect it. Not quite as neat and nice as that. It's going to look more like that. Okay, so we're going to see if we can find that top part with the gonads and things like this, and then underneath we'll find that ring canal that makes up the T. Remember, we call that Aristotle's lantern. We took that out of the sand dollar, right? And I think I mentioned to you back then it will be much more prominent and easy to see in the urchin. So we'll see that today. All right, that's when it's all cleared away. You can see there's Aristotle's lantern. So I'd like to make our dissection approach this way versus taking that mouth out. We'll eventually take the mouth out because that's just kind of soft tissue, a little ring around there. All right, once again, it'll look something like that. See, and these are labeled, so I will bring that back up when it's time. What is the main predator from the video? Sea otters. There they are. How cute, right? Sea otters are pretty amazing. We're going to watch a little video on their contribution.
The name of this project is Chihu til Innisdal in Haida, and that translates to nurturing seafood to grow. And the reason we call it that, we're restoring kelp forests, and kelp forests are an important coastal habitat for many species, including abalone and herring that are both culturally important, and rockfish and other species at risk that require kelp forests to be healthy. So this project wants to emulate what sea otters would do in the system, which is eat a lot of invertebrates. We are targeting sea urchins because sea urchins are hyperabundant without sea otter predation, and they are incredibly voracious grazers of kelp, and so we want to take out these grazers so that we can restore the kelp forest.
I'm still getting hundreds of them every day, right, to thousands. You know, you don't know until you start trying to get rid of these things, just the sheer volume of how many there is out there. The reason why we call them zombies is you get these ones from the deep that have no row in them. They're like running on empty, but they're able to survive. And all they need is that one little chunk of kelp to just keep them going or whatever, just to keep them mobile.
We're doing it this time of year because this is when the kelp actually sends out its spores and lands on the forest floor and starts to grow. So if you can time it so that we remove the urchins in time for the kelp to grow, then we should see recovery by next year.
So if the urchin is underwater and grazing away at everything that's growing, then you can imagine it's like a lawnmower, and it keeps mowing down all the kelp that is living and growing. And so now if we take out those lawnmowers, then we expect these spores to be able to survive and grow into the next kelp forest. Sea urchin is a traditional food for the Haida, and so part of our project is bringing that food into the community. There's a commercial boat working which is bringing in seafood, and they're collecting them and putting them in totes to go back to the communities on Haida Gwaii for food.
When we go down to just smash, there's no discrimination between size, color, or anything like that. We're hammering away on them, but when you're harvesting them for food, you got to be a lot more picky and trying to pick out the right ones. And we just basically go down to an area where that's pickable. We'll use the rake. Usually what I used to do is just grab like 3 or 4 of them in a row, just pluck, 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 and they'll all slowly rise in the water column, and then you just scoop them all in one foul swoop right into the bag, and then just rinse and repeat, work your way along the feed line. You just keep going until that bag's full, and then you have a little balloon on it, fill that up, and then help bring it up to the surface. So this is more or less what you want to see, is when you first crack it, explodes with eggs. You get this nice orange to yellow uni. The yellower the better. That's what the commercial people like, and the people back home that eat it. And then you just kind of more or less clean it up and then slurp her down.
We also know that sea urchins can smell really well underwater, and so they can find food. And we don't know at what rate those sea urchins will want to come back once the kelp starts to restore. And so what we're uncertain of is how much maintenance is going to be required to keep removing those urchins until the sea otters return.
Okay, so you see they were concerned that the sea otter population was down. And because if the sea otter population is down, the urchin population will explode, and that will destroy the kelp. And
Why was the population down?
that I don't know. I guess we tuned in, I guess, a little after that happened. I don't know. So, but at the end, she said, to bring back the sea otter population. Interesting, that's what, 2 weeks in a row now we've talked about capturing things to get rid of them, right? We talked about the crown of thorns, the cots. That reminded me a lot of that sunflower, do they call it sunflower starfish or whatever? Looked a lot like the cot, I think. So here is a sea otter eating, it looks to me like he's maybe eating a crab, but the point being is that their teeth are sharp enough to get through the test of an urchin and other shelled animals. So they're very good. They're also one of the few animals out there that do use tools, right? They'll stay out on their back like this and they'll crack open shells with other shells, like cracking them right there on their belly. Yeah. All right, and we're going to be looking now at kelp farms. So right here in the top left, you can see a map. Does anybody know what that's a map of? Does it look recognizable?
Is it the bottom by like, no.
It's Massachusetts. That's Cape Cod in Massachusetts, right? This is where the Pilgrims first landed, right around here and over here, right? So that's Plymouth, Massachusetts, yeah. So apparently we have some kelp farms off there. It means the water's cool and deep, that kind of thing. And so you can see what we have here, and I think our next video is going to kind of explain some of this to it. They have these, like, what would you call those? Racks that they are hanging them from so they don't have to depend on the holdfast for these guys. And then this is a monitor that's taking inventory of the health of these things and then transmitting that to a computer of some sort. Let's see if this video will give us a little more information on that.
Unlike sort of salmon aquaculture and other things, there just isn't much to see. You just see some buoys floating, but you can imagine it as sort of this underwater garden.
It's farming, just like somebody who has a tomato farm or some sort of vegetable garden. It's just I do it out on the water instead of on land.
It's one of the fastest growing plants on Earth. So we can grow an incredible amount of sea vegetables in small areas.
And we don't have to add any fertilizer at all. But we're just kind of taking something that's happening naturally and trying to organize it into one location so that we can make the most of what's growing. My name is Susie Flores, and I am a Executive Market Development Manager at McGraw-Hill Education. And on the side, I am a kelp farmer. I had heard about seaweed farming, and I wanted to grow some just for consumption. The more that I looked into it and the more I read about it, I realized that it's also a fantastic thing to do for the environment. And then once we saw that there was a possible economic upside for it, we decided to give it a shot.
My name is Bren Smith, and I'm a 3D ocean farmer. I came into this as a commercial fisherman, and I had to be sort of a nurturing arugula farmer in a way, and it was a psychic shift for me. When I first showed up here 15 years ago, my patch of ocean was this barren water, and now it's this whole thriving ecosystem with mussels, clams, oysters, kelp. The challenge is imagine growing in an environment where the soil turns over 1,000 times a day. I mean, we're just getting currents and changeover and nutrients, and that dynamism is what grows sort of a beautiful sea vegetable, but it also makes it difficult for a farmer. The kelp we grow is called sugar kelp,
which is a native seaweed that grows all along the East Coast border.
And what we do is every fall we go out and collect a few pieces of kelp that are reproductive and bring it back to our hatchery, and the little spores attach to pieces of string.
And then we take it back out into the ocean from whence it came, and we outplant it on our log lines, which are submerged about 3 feet underneath the water. The turbidity of the water, the murkiness of the water could impact how much sunlight is actually getting through to the kelp. Kelp gets everything from the water, so as the water current, goes through our kelp farm, it's also bringing with it all of the nutrition.
Kelp needs a mix of like phosphorus, carbon, nitrogen, and sunlight. So my job with the kelp is to find that sweet spot where we capture the nutrients and also the sunlight.
We harvest the kelp in the spring season before all of the other competing species are going to be around.
All the junk that grows on the kelp, the epiphytes, the sea squirts, all these different things that as the water temperatures increase and the oceans essentially wake up, they attack the kelp.
And it doesn't render it completely useless. You still could use it for fertilizer and things like that, but it does mean that it's not pretty enough for people to consume.
But this is a good thing. I mean, we're creating a foundation for the ecosystem, for everything to come eat, hide, and thrive. The economics of kelp farming and ocean farming are in some ways the most powerful piece.
Land, especially in this area, is not cheap, but leasing space in the ocean, it makes much more economical sense.
The fact that overhead is so low when you don't grow fish opens up opportunities for regular folks like me to be out here and starting our own farms. We grow about 10 to 20 tons per acre in basically a 4 to 5 month time.
It is one of the few crops that could be used for food consumption, that could be used for fuel, that could be used for fertilizer.
I mean, kelp, people think that disgusting thing on the beach. But what we're trying to do is really make kelp the new kale and reimagine the seafood plate of the future.
There's no fish flavor to it at all. It's very mild and subtle. If you cut it into noodles and you boil it, it turns a really beautiful bright green color. And then you can throw it in any sort of sauce like you would spaghetti.
Luckily, in the U.S., this is one of the great sort of culinary moments of our history with all these brilliant chefs all around the country, thinking of kelp as not seafood, but as a vegetable. We need to push beyond sustainability in our food system and our agricultural system into restoration, into regenerative crops. Kelp, for example, captures 5 times more carbon than land-based plants.
And one of the things that it likes to absorb through the blades is nitrogen, so it can offset other algae from blooming.
As nitrogen runs into Long Island Sound, for example, it creates these dead zones. Our kelp can actually breathe life. It can capture that nitrogen. This nexus of job creation, economic opportunity, food justice, and environmentalism, that's the sweet spot. You know, what's exciting for me, who's been out here doing this for a long time, is to see Jay and Susie Flores. They're energetic, they're talented, they care about both the economy and the ecology of this. And they're just exactly what the future of ocean farming should be.
I never thought that I would be a kelp farmer. I hope that I'm at the forefront of a larger wave of aquaculture, and I hope that people continue to learn more about this sea vegetable and think about ways it can be infused into our economy and into our diets.
All right, did y'all hear they said they wanted to make kelp the new kale? I don't know how y'all feel about kale, but that's not a selling point for me. But pretty cool that they, lease spots. I can't call it land, really, right? They lease areas where they can go grow this kelp. So that's pretty cool.
I thought kelp needed it to be warm to grow.
No, it needs cooler. And did they say Florida? I felt like she said Florida. East Coast. The east coast of Florida would be cooler than the Gulf Coast. The Gulf Coast, I don't think we can grow kelp at all in the Gulf of Mexico. And we'll see in a future deal about how the Gulf of Mexico is one of those places that's considered a dead zone or a dying zone. Mostly because of the flow of chemicals coming from the Mississippi River and things like that are contributing to that. All right, but other aquaculture, aqua farming we can look at is that we have farmers who will, instead of just going out fishing for fish and things like that, here's our seaweed that's being hung from these buoys right here. And then we have mussels that are attaching. Remember, mussels have those byssal threads and they'll attach to things. They're attaching to some sort of rope coming down here. We have scallops in a type of cage thing. We have mussels, oysters and clams. If they're already in there and growing in there, they're easier to harvest and things like that. Here are some various things that we use kelp for. We use seaweed for. So if I ever ask you if you've eaten seaweed and you say no, I said, well, yeah, you have. If you've eaten ranch-style dressing on your salad, you've had seaweed. But look at kind of things. We have paint, medicines. Here's toothpaste. I don't know, maybe that's shampoo right there. Makeup and other cosmetics. We have over here the most common use over here. We have, look, cheesecake, cakes, salad dressings, anything that has any sort of thickness to it. If you've ever been cooking, use cornstarch to thicken up like a gravy or whatever. Seaweed would do the same thing. It would have that same kind of ability to do that. Looks like we have beverages down here. I didn't know Sam Adams beer uses kelp of some sort. Don't know. All right, so those, I don't know if you're supposed to write few of those things down. Yeah, you need me more light. Write down a few things we get from kelp. It often is used as a thickening agent. And when she mentioned bringing it up as far as eating it, that it didn't have a fishy taste, but I bet you it's salty. Have y'all eaten kelp? It's gotta be salty, right? Seaweed, yeah. So commercial kelp, healthy kelp. We're going to see right here major health benefits of sea kelp. A potent source of iodine. Remember, iodine is a micronutrient we need to keep our thyroid healthy, to keep our metabolism running. Glutathione. Oh, that's good to know. Glutathione is the stuff that keeps our joints nice, and so if we're having any trouble with our joints, glutathione is one of those things that helps with that. Blood sugar control, anti-inflammatory polysaccharides, that kind of plays into the glutathione deal. Virus protection, that's probably because it's boosting your immune system. Blood clot reduction, interesting. So I'm guessing that's where, especially down here, these last ones, or the last three here, would be, or even four, yeah, would be in the drug industry, right? And then, of course, we can eat it. So they do sell some seaweed, a seaweed salad at H-E-B. I thought about getting it, but then I thought I'll save that for the time we have our food day in here, right? Our eating day. I'll bring you some seaweed to eat. Some of these, look, this one says it's fermented. We all know y'all know the power of fermented foods. It's supposed to be really good for our microbiome. I have trouble liking them. I'm not a big fan. Look at this one, sea beet kraut with raw kelp with sauerkraut. And maybe beets, I'm guessing. I love beets. So yeah, I don't know if I can maybe buy some of these. We'll taste some of these, my point being. All right, so here's one. Look at how cute these guys are. Oh, they're holding hands. Okay, so we're going to be doing our lab time, which we are going to take our sea urchins. And notice here, this is the picture of the urchin that doesn't have any of his needles on him anymore. But this is to help us show what we're going to do. We're going to try to cut the top off the bottom. And the way we do this, we're going to have to poke a hole in there and then probably use some scissors. So we'll need scissors for this dissection. And then try to open it so we have the double sides like this. And the bottom side, the aboral side, the oral side, this is the aboral side is the top, the oral side down here. The oral side's going to be more interesting. The top side, the aboral side's going to have those gonads in it. That's apparently the stuff that people eat. Like that guy just slurped it on the boat ride. I'm like, so I'm guessing it's kind of like eating caviar, right? So I'm guessing it's sort of salty.
But
kind
I heard
of a
it
thing.
has like a smooth and like buttery texture.
Really? Okay. I wonder if you sell that. If they sell that somewhere. I'm not sure. I haven't seen it. All right, so we're gonna get started in our lab.